Okay. So let's look at the fifth problem of miscellaneous. So if Z1 is equal to 2 minus I and Z2 is equal to 1 plus I, find mod of Z1 plus Z2 plus 1 the whole divided by Z1 minus Z2 plus 1. Right? So this is what we need to find. So all that we need to do is first find out what is Z1 plus Z2 separately. So what is Z1 plus Z2? It is going to be 2 plus 1, 3, minus I plus I is 0. So Z1 plus Z2 is going to be 3. And Z1 minus Z2 is going to be, so Z1 minus Z2 is going to be, so it is going, see 2 minus I, it is going to be 2 minus I minus of 1 plus I. So 2 minus 1, 1, minus I is minus 12, right? So all that we need to do is Z1 plus Z2 substituted here, Z1 minus Z2 substituted here. Okay. So there is going to be modulus of 3 plus 1 is 4 divided by 1 minus 2i plus 1. So it is going to be 2 minus 2i. Right. If you take the 2 outside, it will be 2 divided by 1 minus I inside a modulus. Right. So first we will divide this complex number with this. Though it is a real number, I call it as complex because you can write it as 2 plus I into 0. Right. So multiply and divide it with the conjugate 1 plus I divided by 1 minus I into 1 plus I is going to be 1 square plus 1, which will be 2 itself. So mod of this 2 and 2 will get cancelled. So basically what I did is 1 minus I into 1 plus I will be equal to 1 square plus 1 square, which will be 2. That is what I wrote here. There is already a 2 in the numerator. They got cancelled. So all that you are left out with is modulus of 1 plus I. So modulus of A plus IB is root of A square plus B square. So this is going to be root of 1 square plus 1 square, which will be root 2. Okay, it is going to be root 2. That's the answer. Okay, can make a note of this. Done. Done with this, take the study material and do the test problems. Okay, shall I proceed? So listen. Sixth problem is, if A plus IB is equal to x plus I the whole square divided by 2x plus 1, 2x square plus 1, then prove that A square plus B square is equal to x square plus 1 the whole square divided by 2x square plus 1 the whole square. Right? This is what we need to prove. So if you observe here, this is not completely in the standard complex number form. Right? So for that, what we will do is, if I take A plus IB here, A plus IB is equal to, if I square this, what will I get? You will have x square plus I square plus 2x into I, the whole divided by 2x square plus 1, which implies this is equal to x square, this is minus 1 because I square is minus 1, plus 2xi divided by 2x square plus 1. Am I right? So compare both the sides. A will be equal to x square minus 1 divided by 2x square plus 1. What will B be equal to? B is equal to 2x divided by 2x square plus 1. So if you observe, the denominator is the same. So what is expected? They are asking us a square plus b square. So observe what I'm going to do now is, for a square plus b square, denominator is 2x plus 1, 2x square plus 1 the whole square, no doubt on that. So it is going to be x square minus 1 the whole square plus 4x square, because it is 2x the whole square. The whole divided by, what are we going to get? 2x square plus 1 the whole square. If you try to compare it, 2x square plus 1 the whole square, we got it. So what is going to happen to the numerator? So if I take x square to be, let's say, L and 1 to be M, so it is L minus M the whole square plus 4 times LM. What is it going to be? It will be L plus M the whole square, because it is an identity. So basically, A minus B the whole square plus 4AB is equal to A plus B the whole square. Okay. So here what will happen? This is nothing but x square plus 1 the whole square, the whole divided by 2x square plus 1 the whole square. Okay. Using this identity, I got this. Suppose you don't know the identity, don't worry. All that you need to do is expand it. So if suppose you expand and write this, okay, this is the final answer. I'm only showing you the alternate step. See. So the alternate step is, when I expand it, what will I get? I'll get x square the whole square. Don't write it as x power 4. Let x square be one term. X square the whole square plus 1 minus 2x square plus what you have? Plus 4x square. So what will you get? X square the whole square plus 1 plus 2x square. So what is this format? A square plus b square plus 2ab. Again, you will get a plus b the whole square. So basically, it is the same identity. Is that point clear? So this is an identity that you need to know. So let me know once you're done with this. Done? Okay. Shall I proceed? So look at the 7th problem. So the 7th question is, let Z1 is equal to 2 minus I and Z2 is equal to minus 2 plus I. Okay. Find A, the real part of Z1, Z2 divided by Z1 conjugate, and B is imaginary part of 1 by Z1, Z1 conjugate. Yeah. So that's what the question is, right? So before we find the real and imaginary part, solve that operation. For the A part, what we will do is Z1 into Z2 divided by Z1 conjugate is there, no? So what is Z1 into Z2? It is 2 minus I into, see, observe, if I take the minus sign outside, can I write this as minus of 2 minus I? Right. So I'll take the minus sign outside, I'll write it as minus of 2 minus I divided by, what is Z1 conjugate? It is going to be 2 plus I. Am I clear with this? So basically, it is minus of 2 minus I the whole square divided by 2 plus I. So what is 2 minus I the whole square? Minus of 4 plus I square minus 4I the whole divided by 2 plus I. So what is I square? Minus 1. So 4 minus 1, 3. So minus of 3 minus 4I the whole divided by 2 plus I. Make sense? Right. But still, this is not a general form. Right? This is not the standard form of a complex number. What we need to do? So multiply and divide it with the conjugate. When you do this, what will you get? So this will be minus of 3 minus 4I into 2 minus I. So it is going to be 6 minus 3I minus 8I minus, sorry, plus 4I square the whole divided by 2 plus I into 2 minus I, it is going to be, which is 4 plus 1. 2 square plus 1 square. Right. So how much will you get? So it is negative of 6 minus 11I. 4I square is minus 4. The whole divided by 5. So what will you get? 6 minus 4, 2. So minus of 2 minus 11I, the whole divided by 5, which will be minus 2 plus 11I by 5. So this is a complex number. So what is going to be the real part of this? So real part of Z1, Z2, the whole divided by Z1 conjugate is equal to minus 2 by 5. This is the answer. Is that clear? So first make a note of this. Now what are the chapters for test? In relations and functions and all, what kind of problems are asked? Range is also taught you. For what functions? எது கொடுத்தாலும் பண்ணுவீங்களா? You know the procedure to do? I remember explaining, but I don't know how to find the range of a function. Do you have your class notes now? Whole notes? Just go home, send me what are all the topics that are taught. If possible, I'll try to make a condensed video and give you that you can learn all the concepts in less than half an hour. If you can give it to me by tonight, it will be helpful. Okay. So I gave you a number, no? Message the notes there and tell that sir wanted these notes. I'll get the forward. I'll have a check. I think first chapter is not an issue, right? Everybody, it's a self-explanatory. It's an easy lesson. Only relations and functions, there'll be some challenges. Shall I proceed? Yeah. Shall I proceed? So, yeah. So if you look at Z1 is 2 minus I, and problem B is imaginary part of 1 by Z1 into Z1 conjugate. Right? If you observe, what is Z1 into Z1 conjugate? Remember, a complex number into its conjugate will always be a real number. Because it's a square plus b square, right? So here it is going to be 2 square plus 1 square, which is going to be 5 itself. So what is going to be the imaginary part of 1 by 5? Obviously, it is 0. Right? Because it does not have an imaginary part itself. It has only real part. So imaginary part is 0. So this is the answer for the second part. Okay. So the eighth question is, find the real numbers x and y such that x minus iy into 3 plus 5y, right? You're doing the product of these two complex numbers, x minus iy and into 3 plus 5y is the conjugate of minus 6 minus 24y. So the relation is, if you do the product of these two complex numbers, you will get a complex number. So what is that complex number? How is that complex number, which is a resultant of product, related to this? It is a conjugate. Suppose I call this as z, right? So z is equal to x minus iy into 3 plus 5y. Two terms into two terms. I'll totally get 4 terms. So among the 4 terms, what is going to be the value? It will be 3x plus 5x into I minus 3y into I minus 5y I square. Right. So this is going to be how much? 3x plus 5xi minus 3yi. So I square is minus 1. So minus of minus will become plus. So it will become 5y. Right. So I'll take all the real parts. 3x plus 5y plus I into 5x minus 3y. If I call this as z, okay, I'll call this as z1. So z1 is minus 6 minus 24i. So what is the conjugate of this? So z1 conjugate is minus 6 plus 24i. Okay. So according to the question, z is equal to z1 conjugate. This is the conjugate of this number. So z is equal to z1 conjugate. So what is z? 3x plus 5y is equal to, so from 3x plus 5y, if I compare the real parts, 3x plus 5y should be equal to minus 6. Similarly, 5x minus 3y should be equal to 24. Am I right? Now, if you observe, these are linear equations in two variables. We can use any of the methods and solve it. So we'll use elimination method. So I'll multiply the first equation with 5, second equation with 3, eliminate x, find y, substitute it back. So first equation multiplied with 5, it is going to be 15x plus 25y is equal to minus 30. What about this? I'll multiply the second equation with 3. 15x minus 9y is equal to 72. So subtract both. Okay, 15x and 15x are gone. 25y plus 9y is going to be 34y is equal to minus 102. So y will be equal to minus 102 divided by 34. So how much will that be? It will be 3. Because 4 3s is 12, right? So it should be 3. So minus 3 will be the value of y. Take that and substitute it in any one of the equation. Let me put it in the second equation. Then I'll get 5x plus 9 is equal to 24. So 5x is equal to 24 minus 9 is 15. X will be equal to 3. So as per this problem, the value of x is going to be 3, which is a real number, and y is minus 3. So that's the answer. Right. Shall I proceed? Any doubt? Clear? So the ninth question is, find the modulus of 1 plus I divided by 1 minus I minus of 1 minus I divided by 1 plus I. So we need to find the modulus of this. Right? How to solve this? So take LCM. It will be 1 plus I the whole square minus of 1 minus I the whole square divided by 1 minus I into 1 plus I. It will be 2. It will be 1 square plus 1 square, which is 2. Now tell me what is A plus B the whole square minus A minus B the whole square. So we know that A plus B the whole square minus of A minus B the whole square is 4AB. Right. So when I write 4AB here, what is it going to be? It will be 4 into 1 into I divided by 2. This and this will get cancelled. You will have 2I. So this complex number, right, the operation between two complex numbers, the resultant is 2I. So if I call this as Z, then what are they asking? They are asking us the mod of Z. So what is mod of Z? It is going to be root of 0 square plus 2 square, which is going to be 2 itself. See, suppose you have only real part or imaginary part, the magnitude of that is going to be the modulus of it. So for example, you need not write this. What is the coefficient of I? 2. That will be the answer. Yes. If at all you have only real number or imaginary number, only imaginary number left out, that number which is there will be the answer. For what? For the modulus. Okay. Clear with this? It's a simple problem, no? So mark 10th, 10th and 11th, actually 10, 11, 12, 13, 14, all are important. They can be asked. So 10 to 14, you can mark them as important. Just at least write it in your notes. Problem number 10 to 14, mark them as important. Shall I proceed? Those are online. Are you able to understand?
Yes, sir.
Okay. So the 10th question is, if x plus iy the whole cube, if x plus iy the whole cube is equal to u plus iv, then show that u by x plus v by y is equal to 4 into x square minus y square. Right? So u by x plus v by y is equal to 4 into x square minus y square. So problem is very simple. If you observe, left hand side you have cube of a complex number, right hand side you have the standard form of a complex number. All that you need to do is expand this, compare the real terms, compare the imaginary terms, take and substitute it here, you will get the answer. Okay. So here to look at the solution, what is the expansion of this? It is going to be a cube plus b cube plus 3a square b plus 3a b square, right? This is equal to u plus iv. Okay. So here if you observe, you will have x cube plus I cube into y. I cube is I. It is minus 1. Sorry, minus I. I cube is how much? Minus I into y. Plus what you have here? Here you have I into 3x square y. So here you have I square, which is minus 1. So you will have 3 minus 3x y square is equal to u plus iv. Oh, sorry, y cube. So here it will be minus I y cube. Okay. So I think it is balanced. X cube minus I into y cube plus 3x square. Y I is taken out, minus 3xy square is equal to u plus iv. So collect all the real terms. If you observe, from these two terms, these are the real terms. What can I take out common? I can take out x common. So it will be x square minus 3y square. Right. From these two terms, I can take out I, y as common. So that it is going to be, no, if I take out I, y outside, it is 3x square minus y square. It is 3x square minus y square is equal to u plus iv. I hope the step is clear. Right? So comparing u on both the sides, u will be equal to, sorry, comparing the complex numbers on both the sides, u will be equal to x into x square minus 3y square, and v will be equal to y into 3x square minus y square. So if you observe the problem itself, they need u by x. So bring the x to the left hand side. So u by x is equal to x square minus 3y square, and v by y is equal to 3x square minus y square. So you need to add them according to LHS. When you add them, u by x plus v by y on the LHS will be equal to x square plus 3x square is 4x square minus 3y square minus y square is minus 4y square. So take out 4 common, you will have x square minus y square. That's what they have asked. Is the point clear? So this is how you solve this problem. So the exams are without break, continuously, without break. So you go for 3 hours and then come back. They are from 22nd to, 15, 17, 17th till, or next week itself it's done. in that? What is the first exam? Then English, physics, then chemistry, math. No time. Fully occupied. We are going to a school for Korean. But you tell me the topics, I can help you. That's why I told you, message me before today. Shall we proceed? See, 11th is a slightly complicated one. Concentrate. So the 11th, yeah. So 11th question is alpha and beta are two different complex numbers, right? And what is the condition that is applied on beta? Mod beta is equal to 1, right? Then find the value of mod of beta minus alpha divided by 1 minus alpha conjugate into beta. So what is going to be this value? Okay, suppose I take this to be Z. Okay, observe. So all that we need is, we need mod of, sorry, actually, if I take this beta minus alpha by 1 minus alpha conjugate into beta as Z, what we want is mod of Z. Okay, so remember, whenever you see these kind of conjugates and you have the modulus being given, the property that we can think of is mod of Z square itself is obtained as a product of Z and Z conjugate. So mod Z square is equal to Z into Z conjugate. Are you able to understand? So here mod Z square means this whole thing is equal to, can I write this as beta minus alpha divided by 1 minus alpha conjugate beta into beta minus alpha divided by 1 minus alpha conjugate beta, the whole conjugate. Can I write it like this? Okay. So there is a property with respect to the conjugate as well. Z1 by Z2, the whole conjugate can be written as Z1 conjugate divided by Z2 conjugate. Means this bar will get split to each numerator and denominator. After that, what will happen is, if you observe, you have beta minus alpha. No, suppose Z1 minus Z2, the whole conjugate is written. This is the same as Z1 conjugate minus Z2 conjugate. Okay, this is going to be Z1 conjugate minus Z2 conjugate. Are you able to understand? Now observe. So I'm going to leave it as it is. Beta minus alpha divided by 1 minus alpha conjugate into beta into this one can be written as beta conjugate minus alpha conjugate divided by 1 conjugate is 1 only. 1 minus of alpha conjugates conjugate into beta conjugate. Am I clear till this? So what I did here is, first I applied this property. So I actually avoided one step. I should have actually written beta minus alpha the whole conjugate divided by 1 minus alpha conjugate into beta the whole conjugate. Then I applied the second property. Right. The third property that you need to know is Z1 conjugate is Z1 itself. So the conjugate of a conjugate is the original complex number itself. Okay, it's very simple. You need not remember like a property. I'll tell you, see, if I have A plus IB, this is, let me call it as Z1. Then what is Z1 conjugate? A minus IB. Then what is the conjugate of Z1? Z1 conjugate is A plus IB, which is nothing but Z1 itself. So when you apply the operation twice, you will get back the original value. So why I'm telling that is, you have alpha conjugates conjugate, which is actually going to be alpha itself. So in the numerator you have 4 terms, denominator you have 4 terms, numerator you have 2 terms, and here you have 2 terms. So 2 into 2 will give you 4, and here also it should give you 4 terms. So observe, this is going to be beta into beta conjugate. I'll write it here. So this will be equal to beta into beta conjugate minus beta into alpha conjugate minus alpha into beta conjugate plus alpha into alpha conjugate. So beta into beta conjugate minus beta into alpha conjugate minus alpha into beta conjugate minus of minus plus alpha into alpha conjugate. The whole divided by 1 into 1, 1 minus alpha conjugate is alpha itself. So 1 minus this whole term, I will write it as alpha into beta conjugate minus alpha conjugate into beta plus alpha into alpha conjugate into beta conjugate. Observe, 2 terms multiplied 4 terms. So alpha conjugate into alpha, beta into beta conjugate. Am I clear with this? Right. So using the property again, Z into Z conjugate is equal to mod Z square. What I can write beta into beta conjugate as mod beta square. So beta into beta conjugate is mod beta square, because I have the value of mod beta. Yes. So this will be equal to mod beta square. So what can I do with this? Nothing. I can only take the minus sign outside. So if I take the minus sign outside, what will I get? Alpha into beta conjugate plus alpha conjugate into beta, right? Plus what can I write this as? Using the same logic, mod alpha square plus mod alpha square the whole divided by 1 minus, if I take the minus sign outside, what will I get? Alpha beta conjugate plus alpha conjugate beta plus, observe, alpha into alpha conjugate is mod alpha square. Beta into beta conjugate is mod beta square, but mod beta square is 1. So I'm not writing it there. Right. So what am I going to get? This mod beta square, if I replace it with 1, right? 1 minus of alpha beta plus conjugate plus alpha conjugate beta plus mod alpha square, same as the denominator. So this and this will get cancelled. You will be left out with 1. This is what actually? This is mod of beta minus alpha by 1 minus alpha conjugate beta, the whole square. That is where we started with, right? This comes out to be 1. So what is going to be the mod of that? 1 only. That's the answer. Is the point clear? Iduva. Illa, see, mod beta square I replace with 1. Okay, then it will be 1 minus this thing plus mod alpha square, the whole divided by same thing. Numerator and denominator are same, that's why I cancel. Online, those who are online, clear? I hope you could understand this problem.
Yes. Yes, sir.
Yeah. Shall I proceed? Yeah, copy it. Done? So 12th question is, find the number of non-zero integral solutions of the equation mod of 1 minus I to the power x is equal to 2 power x. So what is that we need to find? We need to find the number of non-zero integral solutions. Okay. So for that, if you observe, what is mod of 1 minus I? It is going to be square root of 1 square plus 1 square, which is going to be square root of 2. So mod of 1 minus I the whole power x will be square root of 2 to the power x, which will be 2 power x by 2. Right. So if I take then substitute it here, you will get 2 power x by 2 is equal to 2 power x. So which implies x by 2 is equal to x. This implies x by 2 is equal to 0. Why x by 2 is 0? Because x minus x by 2 is x by 2, that will be 0. So I take one x by 2 to the other side, x minus x by 2 is 0, which implies x is equal to 0. So what is that we are supposed to find? We need to find the number of, not non-zero. It is the number of non-zero integral solutions that are possible. So 0 itself, so 0 is an integer accepted, but it is not a non-zero integral. So there are no non-zero integrals that are possible. So what will be the answer? Answer will be 0 non-zero integrals will be possible. See, x is equal to x by 2. So x minus x by 2 is 0. Don't cancel x and write 1 is equal to half. Okay. Okay. So x by 2 is equal to 0, which implies x by 0. That's what I wrote. I just brought that to the other side. Okay. See, the next two problems are easy only. The reason I asked you to mark them as important is for the idea, how to think. Shall I proceed? So the 13th question is, if a plus ib into c plus id into e plus fgh only, e plus if into g plus ih is equal to capital A plus I into b, then what is that we need to prove? Then we need to prove that a square plus b square. Okay, the pattern is a square plus b square into c square plus d square into e square plus f square into g square plus h square is equal to a square plus b square. So problem is simple. Whenever a complex number is given and you are expected to find out a square plus b square, then what is that you need to do? Either find the modulus or multiply that complex number with its conjugate. These are the two logics. Okay. So here what we can do is, we'll take the modulus on both the sides. So when you take modulus on both the sides for this, I get mod of a plus ib. See, actually the modulus is applicable from here till here. Okay. But mod of z1 into z2 can be written as mod of z1 into mod of z2. Right. When you do that, mod of a plus ib into mod of c plus id into mod of e plus if into mod of g plus ih is equal to how much? Mod of a plus ib. So how much will this be? It will be square root of a square plus b square. This will be square root of c square plus d square. This will be square root of a square plus f square, and this will be square root of g square plus h square under a root, and this will be square root of a square plus b square. So when you square on both the sides, what will you get? You will get the expected result. So a square plus b square into c square plus d square into e square plus h square plus, sorry, not plus, into g square plus h square is equal to, that's it. Okay. Shall I proceed? Yes. So 14th problem is 1 plus I divided by 1 minus I, the whole power m is equal to 1. So if this is the condition, find least positive integer value of m. Right? So we need to find the least integral value of m. So how to do this? Obviously, if they will give you division of two complex numbers, first convert it to standard form. What will you do? Rationalize it. So 1 plus I divided by 1 minus I. So 1 plus I divided by 1 plus I. So multiply and divide with the conjugate. So 1 plus I into 1 plus I is basically 1 plus I the whole square divided by 1 minus I into 1 plus I is going to be 2. 1 square plus 1 square, which is going to be 2. So this will be 1 plus I square plus 2I, the whole divided by 2. Am I right? So what is I square? Minus 1. So minus 1 and 1 are gone. So what is that you are left out with? 2I by 2, which is going to be I itself. So this is the one which is inside the bracket. This is the base. So, but what is the question? This base to the power m. Base comes out to be I. So base to the power m is equal to 1. So what should be the least value of m for which you are going to get 1? See, m can take the value of 4, 8, 12, so on. Basically the multiples of 4. But they ask the question about the least integral value. So the value of m should be 4. That's it. Clear? So that is all with this chapter, right? So any other questions? Actually, there are no doubts today. We can wind up early. So tomorrow, do you want me to start with linear inequalities, the next chapter? Can I? Or do you have any topics that you want me to help you with? ನಾಳೆಗೆ ಏನದು? Relation and function. Okay. Physics, I can't do. But math, even if I go slow, I can complete by this. Physics, I can't. We're still in fifth chapter. Just some problems from relations and functions. Revise the theory and come, okay? So, any questions?
No, sir.
Okay. No doubts, we can wind up for today.
Yes, sir.
Yeah.
Sir, can we have extra questions tomorrow? Can we do extra questions in this chapter tomorrow?
Extra?
Extra questions on this chapter?
Which chapter?
On this chapter.
You will already have it in the study material.
What?
Did you get the study materials?
I'll check.
Yeah, check that. You will have the questions in that itself. You can do that. And you will have a weekend assignment also being uploaded in this. So we get the questions on. Yeah.